Okay, yes, great to see you here. So our project is a what we call AI CyberLake, which is a good name suggested by NSF. We will provide live evaluation of attack detection algorithm on a real world security data set that we sourced from the backbone of the AI infrastructure, which is a National Center for Supercomputing Application. So for the context, we have been curating this data set for 25 years. So NCSA at Illinois have kept a detailed record of all the security incident. In that time, we have more than 30 compressed terabyte of log, more than 300 security incident with the ground truth, and more than 100 billions of connections that we have recorded in this data set. So not only the attack at NCSA, but attack at the US infrastructure that run through NCSA is collected in this data set. So we feel like this is a great interest to the community. First is to provide the static data set so that you can look back in the history, as well as a live data lake so that you can plug your own detection algorithm in the live stream of the production network. And the next step is to provide the detection and recovery, not only to gain the insight from the data, but provide detection and recovery. And this is a great need from the community as motivated in the prior project. So what we are different is that we kind of augment the existing project on the network flow and system log. We also provide the view on the other aspect of the emerging attack. For example, the cryptographic metadata that is quantum resistant or not, the job execution trace of the AI workload so that people can look at the AI bill of material to see whether there is any backdoor in the AI model. And also look at the authentication, who is authorized to run the workload from what institution in a federated manner. So those are the example of the kind of metadata that we provided on top of the traditional security data set. And we leverage the Zeek security monitor and our auditing system so that people at other national lab are familiar with the kind of format that we provide. And NCSA is a hub of scientific computing. So we hope that by looking at the single data lake here, we'll provide a 360-degree view of the attack activity on the US scientific infrastructure. The benefit, I think, is to evaluate the novel attack in the horizon. For example, the zero-day vulnerability in the accelerator or the backdoor in the secure shell, or to see how the distribution shift in the dataset affect your model, because the attack is constantly changing. The model training for today may degrade the performance tomorrow. So we can look at the distribution shift. And there are obviously some risks in here. We do this in a open science domain, so the adversary may be aware of the internal detection logic, and we have to be careful about leaking the PII data. But the benefit, I think, is outweighs the risk, is that we can provide a robust evaluation of security detection method on the real world workload. And we will propose a kind of new, what we call fair secure. So fair is a standard to provide the findable, accessible, and for data set. What we propose is a secure element to that, which we hope could be a standard to disseminate the data to the community. So far, several teams from Illinois have worked directly with us to digest this data set. So by working directly with the PI team, we can provide the domain expertise to interpret what is happening in the data, because as you know, it's not the matter of showing the data, but understanding the data and providing the context information, which is more important. And that is what we have resolved in several publication in Unix security and QCE. In the future, during the duration of this project, we will automate this process so the data can be streamed to the interested partner, because as you know, the scale here is in the order of hundred of terabyte. It is not simply be able to copy to another endpoint. We have to do that in a streaming manner, and all the PII should be anonymized on the fly. And there's an interest form here that you are welcome to go and fill in the interest form, and we will get back to you. Now I would like to go just 2 minutes to focus on our plan to enable the what we call fair, secure sharing of the security data lake here. So what we want to provide is to provide a concrete a case study of how to apply the FAIR principle in the security data lake. So the first thing is to make the data findable. We plan to register the AICyberLake as a virtual organization on the Open Science Data Federation (OSDF), so that people interested in can use a unique global identifier to access our dataset. So these are the schema that we are proposing, so that people can access the published dataset, which is intended for the public, and the protected dataset, which are intended to be embargoed during the research time, but eventually will be published. And this makes the data schema public and findable, because we rely on the very well-defined metadata that Zig has parsed the network dataset. And we want to make this programmable and interoperable, so that people can use the API, familiar API and SQL query to query on our stream of data that would be anonymized on the fly. So only the record of your interest will be streamed to you and anonymized on the fly. So that is how we will realize the FAIR principle. And what we added in here is secure, what we call fair secure for security data set. So we will anonymize the PII on the fly, as I said. We are talking to the Usenix Security Conference, because there is a push for open science in Usenix security. So we want to work with them so that our project will work with the OSDF to provide the data artifact for Usenix security submission, and the community can evaluate it in the review time and reproduce it at the publication time. And we intend to work with NIST to bring this into a standard that the community can refer to. Most importantly is research security. How do we actually secure the kind of research that we are doing? NCSA is a mixed environment of the open science system and the closed system. So we have explicitly um, showing what kind of data we are allowed to collect from the open science system. For example, the Delta AI system funded by NSF to satisfy or the mandate of NSF regarding the data sharing. The user accesses will need to sign the usage agreement, which we will derive from the access program, which already provide good framework on user agreement. And we would need the user, the US-based PI and the student to certify that they would use this data set in a predefined manner as outlined in the agreement. All of the access pattern and usage statistic will be measured to find the anomaly. So this is intended to be a service, not a touch and go, or to handle the data set to other people so that they can take off with the data set. So we will look at the usage statistic to find the anomaly in using our own data security CyberLake. So that is a summary of our work.
Wow, great. So a couple interesting points that, from the broader group here that, that at least I'm thinking, and maybe the NDP and OSDF folks have similar view. Uh, I think there's an interesting distinction here between what we were seeing before about sort of labeled data, static data. I don't think LLM Doll was planning to offer real-time access to the data. But I may be off on that. But and here we have an interesting access of sort of on the fly data access, which is great. I will show some of my bias. I look back on the old route views days, right, where you've got kind of a mix of static data, but there's also the ability to get route views, BGP updates in real time, and an in between. So just two questions for the AICyberLake team, right? Is okay, is the security standard, right? A new NIST secure standard is definitely of interest, right? Be interested to see how that kind of plays out, and if NIST is the right place to do that, or how we do that. So there'll be some interest on that. Would love to hear from all the teams and OSDF and NDP over time as to how that evolves. The other one, just kind of as a tangent, is both Amy Apon and myself are either by choice or by force, kind of now deeply enmeshed in some research security questions. And there's definitely some interesting stuff to do there as well. So, but I think this brings some interesting twists to the data, that taking it from a different data access angle than the previous one. I don't know, is that sounding right to people, or what am I missing?
I definitely a streaming interface introduces challenges. I am wondering and would like to talk more with the project on how authorization is going to work, because it seems that if I want to access an object or to get a stream, I have first of all to show up at the door that they provide and get authorized to do anything. And I assume they will manage the authorization process. The question is, do you generate a capability for OSDF to present the data, to deliver the data, because you don't want for every packet for somebody to show up at your door. You want to authorize it and move on. So at least this is an aspect that we need to better understand, given the fact that this data is fair, but it's fair for authorized, or you want to monitor who is accessing, which is a similar aspect of the ecosystem. Now, streaming is interesting, and there's always a question of what happens if you have a breakdown somewhere in the pipes. What is the semantic of this? So yes, Dan, it gives us opportunities to innovate or to mess up, depending on how you want to look at it.
Yeah, I think those are great questions from Dan and Miran. So for the authentication part, there are two things. One is authenticate the identity of the user, and we intend to use a CI logon, which is a federated authentication service we have here at NCSA, and we don't want to manage user password. That would be managed by the institution. So
yeah. I know Jim Basney. He was my PhD student, so we are using CI logon, but I'm talking more about the authorization. Let's assume that you or CI logon authorize. Took the identifier and say, fine, we are happy with it. but then it comes to the point where OSPF has to deliver the data. And do you give us an authorization? How do we manage the authorization and all that? Do you hand over the authorization to the user so they can be presented? Is it a cookie? I think it would be useful for us on OSPF to have a chat with you and to better understand how the thing works end to end.
Yes, yes, we will look at the scope. I think the term, we will look at the scope of the data access, and we would define the specific, like public scope, embargo scope, and specific scope for the project here.
Yep.
But do you still want to know, even for the public, who it is? I don't know.
I think this is another one that this is kind of achieving what we wanted, is kind of sparking the initial discussion. There's a lot of interesting stuff to follow up on there, and I hope that, you know, for the teams in general, there's some interesting overlap here on, you know, okay, what's, yeah, I don't think anything in here is duplicative, but I think there's a lot of potential for linkage. And so if anybody's interested in sort of like what exactly is a fair, secure standard, right? There's lots of opportunity to engage. I think it's a great idea. You know, how do we fit the streaming data and the long-term data? Anyway, so lots of good stuff. I'm just going to kind of prime some of the fun things there, and I think there's more to follow up on.